AB Calculus Note Card 9, Definition of a Derivative. This is the 9th of the video lessons that were inspired by Stacy McMullen in her development of the note card system. And we get to definition of a derivative. Analytically, definition of derivative of f, function f at x equals the limit of difference quotient. And this is a difference quotient, f prime of x equals the limit as h approaches 0 is f of x plus h minus f of x over h. It is a slope generator. Graphically, the derivative function at a point P is the slope of a tangent line. So going back to note card 1, we have a little roller coaster here. So if we have a roller coaster, it has a bend that goes something like this, and we want to find the slope of a tangent line at a point like I'm drawing right here. If we take points on either side of where we want to evaluate the tangent line at a point and bring these secant lines progressively closer, infinitesimally closer, we will eventually, through limiting process, find the exact slope at a point. So that's what we're doing. And the most common definition of derivative is the one I'm circling here now, but also we can have the limit as x approaches a of f of x minus fa over x minus a. Let's go on to example problems. 1. For f of x equals negative 5x plus 4, use the definition of derivative to find a, f prime of x. So according to the definition of derivative, f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So now we're going to apply the definition of a derivative here. And so that's going to be equal, in this case, to limit as h approaches 0 of, we have negative 5. Instead of putting x, we're going to put x plus h, and then the rest of the function plus 4. And we're going to subtract f of x. We're going to have minus negative 5x plus 4 over h. And now just coming down below, we have the limit as h approaches 0 of, we have negative 5x minus 5h plus 4 minus negative 5x, which is going to be plus 5x, and we're going to have minus 4 over h. And now we have some cancellations. Negative 5x plus 5x, 4 minus 4. So we're left with limit as h approaches 0 of negative 5h over h. And if we plug in 0 for h, we see we're going to get 0 over 0. But if we cancel h over h, we have a limit as h approaches 0 of negative 5. And if we plug in 0 for h, there's no h to plug in here, so we're left with negative 5. And now part B, very similar, except instead of x, we're going to use 2 in the place of x. So we have f prime of 2 is going to be equal to limit as h approaches 0 of f of x, which is 2, plus h, it will bring plus 4, minus negative 5 times 2 plus 4 all over h. And so simplifying, we have limit as h approaches 0 of, we have negative 10 minus 5h plus 4 plus 10 minus 4 over h. And then negative 10 plus 10 cancel, 4 minus 4. We're left with limit as h approaches 0 of negative 5h over h, which leaves us where we were before, right? For part A, limit as h approaches 0 of negative 5, which equals negative 5. Okay, next problem. Evaluate limit as h approaches 0 of 6 times quantity x plus h squared minus 2 times quantity x plus h plus 7. And so in the definite derivative, this part here that we're subtracting is going to be our function, in this case f of x. And this first part over here is going to be f of x plus h. So let's go ahead and work all this below. So what we're going to have is equals limit as h approaches 0, and we're going to have 6 times, we're going to expand this quantity x plus h squared. So we're going to get x squared plus 2xh plus h squared minus 2x minus 2h, and then we're going to have plus 7, and then we're going to just continue here. We're going to have minus 6x squared. Let's see, that's minus negative 2x, so that's going to be plus 2x, and we're going to have minus 7, and that's all going to be over h. So now distributing we're going to have in the numerator 6x squared plus 12xh plus 6h squared minus 2x minus 2h plus 7 minus 6x squared plus 2x minus 7, and that's all going to be over h. So we have 6x squared minus 6x squared. We have negative 2x plus 2x. We have 7 minus 7. And we're going to bring down everything else. Limit as h approaches 0 of what we have left here, which is just going to have h's in it. So we have 12xh plus 6h squared minus 2h. And I think everything else is accounted for all over h. And what's that? That is going to be equal to, and I guess I'm just going to continue to the right here, is going to be equal to limit as h approaches 0 of, we're going to have 12xh over h plus 6h squared over h minus 2h over h. So I've separated all these, and what we're going to get working below is limit as h approaches 0 of h over h cancel each other, so we get 12x. We're going to have 6h squared over h, so we're going to end up with plus 6h, and then we're going to have h over h cancel each other, so we're going to have minus 2. And when we substitute in 0 for h, we're going to end up with simply 12x minus 2. So 12x minus 2 is going to be our answer here. Next, 3. If f of x equals 2x squared plus 1, then limit as x approaches 0 of f of x minus f of 0 over 2 over x squared is, well, we can just substitute in here, equals limit as x approaches 0 of, we're going to say f of x is going to be 2x squared plus 1, okay, and then minus f of 0. Well, f of 0 is going to be just simply 1. So we have minus 1 over x squared. Now, we're going to have 1 minus 1 cancel each other. So limit as x approaches 0 of, we have 2x squared over x squared. Now we have, again, 0 over 0, but x squared over x squared cancel each other. So our answer is going to be limit as x approaches 0 of 2. And what is that going to be? That is going to be equal to 2. Okay, last example problem, which is a multiple choice thing here. If f of x equals x cubed minus 2, which is equal to f prime of 4. Again, we're looking for the definition of derivative, limit as h approaches 0 of f of x plus h minus f of x over h. Okay, well, let's see which one has the form here. Limit as h approaches 0. We have x cubed minus 2. Well, this is going to be, if that's x, there's x plus h. Here we have 4 plus x. So this is not going to work here, so our correct answer is going to be Roman numeral 1. Anyway, this is just a smattering of little problems using definition of derivative. Look forward to number 10, which we're going to go into derivative rules. Good luck, and thanks for viewing.